Alright, in this problem we have what we call the power function, and I need to determine which of the following statements is not true. Now my assumption is that this is multiple choice, and it's going to be on part 1 of your exam, so only one of them must be not true. Therefore the others must be true. Well, if you use your information or your background on even-odd functions, you know, since we just finished doing them, that a function which is even is also a function which is symmetric with respect to the y-axis. So either these are both true or they're neither one is true. So since we only are looking for one statement that's not true, I can use the process of elimination and say it cannot be A and it cannot be B. Because if this is true, this must be true. Therefore, not one of them can be false. If that makes sense to you. Alright, so I have the following left. I have C, which says the range of this function is all real numbers. And that it says the end behavior, remember, as x approaches infinity, that means you're going to the right of the graph, f of x is approaching infinity. Well, let's see what happens. For this function, I can think of it as f of x is equal to the cube root of x squared. That's an interpretation of this rational exponent. And I can make a table of values. Well, let's look at this for a minute. First of all, can you take the cube root of a positive number? Of course you can. Can you take the cube root of a negative number? Of course you can. So any number will fit in this domain. But when you square your result, it will always be what? It will always be positive. So let's take a look at our table of values, which is what most of you will probably want to set up. Remember, this is not a calculator, so you're going to have to be smart about this. I want to put in a value that I can take the cube root of. And since 8 is a perfect cube, I'm going to use negative 8 as an input value, and the cube root of that is negative 2. But when you square negative 2, you get a positive 2. I'm sorry, when you square a negative 2, you get a positive 4. My next number I want to input will be a negative 1, because that also has a perfect cube root. The perfect cube root of negative 1 is negative 1. And when I square it, I get positive 1. I also choose to put 0 here. When I take the cube root of 0, it's 0. When I square 0, it's still 0. And then when I put my other two values in, I chose x values positive values for x. And that gave me my table. So, what I'm looking at here is a graph. Let's take a look at this graph. Where I have a negative 8, let's say, and a positive 4. And I have a negative 1 and a positive 1. And I have a 0, 0. And I have a 1, 1. And I have an 8, 4. So what do you notice? That this graph, no matter whether I put in a positive or negative x, my range values are always going to be positive. Which means this cannot be true. But this is true. This should be D. I marked the wrong one. Okay, so this is not correct. Oh, I'm sorry. This is correct. And this is not correct. Because the range value is not all real numbers. It is only positive ones, whatever that graph looks like. Okay?